we can move on to the pressure the pressure in a gas. The pressure in a gas. Let's all take our memory back home. If we can have a container that has a lid and that can easily be opened, okay, let's make it to be empty and then place it on fire. The air that it contains will force the lid open, and you will hear a very loud sound. Boom! The lid will be flying, will fly off. Why? What happens? It is because the pressure of the gas has increased due to temperature increase. And that pressure can no longer be held by the force on the container lid. So the pressure becomes greater than the force it can withstand. Hence, the forceful opening and making it to do what? To fly off. Now, over here, we look into pressure in the gas and deduce some mathematical formulation. Now, pressure in a gas. Pressure in a gas. There are three things to be considered. Three variables. See, the three variables are considered. Namely, the temperature, that's T, the volume, that is V, and the pressure, that is P. We keep one of these constant and then vary the two out of the three. So now let's look at this. We have a container like this, and we have this. The temperature in this case is kept constant. This is the piston, and this is the plunger. The temperature is kept constant. With the aid of the plunger, we push the piston down. The pushing must be gently done so that because of the collision of the particles of the gas, the temperature will not change. So the volume and the pressure now become our variable. As we increase the pressure gradually, the volume also does what? Reduces. So at a point, the pressure or the piston now falls to this. So let's assume that the initial volume was V0 and the final volume V of Earth. At that time, we have the corresponding value of the pressure P0, and over here, we have the final pressure also as the P final. What is happening here? We will realize that as the pressure increases, what happens to the volume? The volume, of course, reduces. So this inverse variation case. And we can put up a very powerful equation as this. P varying inversely as the volume. As the pressure increases, the volume decreases. That's what the law says. And this is referred to as Boyles Law. Boyles Law. The first person who investigated this, that is his name. The law was named after him, Boyles Law. So Boyles Law, in essence, states that in the fixed mass of a gas, as the pressure increases, the volume decreases. And so the pressure is inversely varied or varied inversely as the volume. So the Boyles Law it states that the pressure applied varies inversely as the volume. When the temperature is constant. Over here, we can continue with this to establish the what? So from here, if we choose, since we choose T to be constant, but let's represent the K to be the constant. So from here, we have P being equal to K over V. And therefore, the constant becomes PV. If it is so, then we can put up an equation that P1 V1 is equal to P2 V2. This is applied to any gas problem wherever we are informed that the temperature is constant and the pressure and volumes are being varied. See, provided T is constant. Okay, that's the first law we consider. That is the plunger, and this is the piston. And volume V0 is originally assigned into the container, and heat is then applied at T0. Because we are not adding any pressure here, we are not adding any weight on the plunger, the mass or the weight of the plunger and the piston remains the same. So over here, as the heat is applied, what happens? The temperature changes. The volume, of course, will equally change. The pressure, agree with me, that if the piston cannot move, then we are changing the pressure. You see, but the pressure will remain constant as long as it is able to push the piston up. Wherever the pressure of the gas becomes equal with the pressure due to the piston will not move. And it is naturally like that. When I'm exerting a force on anybody, And the person also is exerting the force or mean in the opposite direction. If our forces are equal, there will be no motion. But if the person's motion is, if the person's force exerted on me is greater than what I'm exerting on him, definitely I'll be compelled to move towards him. It is just in this case. The weight of the person here is exerting a pressure or sets up a pressure. If the pressures in the gas and that due to the external one are equal, the piston will not move. Where the pressure due to the gas is greater than that of the external one, the piston will move upward until they become equalized again. So that is why we are saying that the pressure is constant. And you will agree with me here that as the temperature increases, the volume does what? The volume also increases. Why the pressure is kept constant. So we can put up an equation in this form. Situation where pressure is kept constant. While the volume and the temperatures are varied. What did we establish? Established the volume is directly proportional to the temperature. As the temperature increases, the volume also rises. When pressure, P, is constant. This is known as Charles' law. Known as Charles' law. The Charles' law states that in a fixed mass, it states that in a fixed mass of a given volume of mass, or a given volume of gas, the temperature varies. Sorry. The volume varies directly as the temperature. That is expressed mathematically there. And so, if we introduce a constant, K, we have this. V equals V over T equals K. Hence, we have V1 over T1 equals V2 over T2. And that is what is found there. So over here, we've kept the pressure constant. In the previous one, we kept the temperature constant. we are going to look into the situation where we are going to keep what? The volume constant. So it will remain the pressure and the temperature that will vary. Let's look into this and see what happens. In this case, the piston is not going to be what? Going to move, because we are talking of constant volume. We are talking of the constant volume. The piston is going to be fixed because we want the volume to remain fixed. And so, that is fixed. We introduce the same volume here, and the volume is kept constant, sorry. So we are looking at the pressure and the temperature. At the P0 pressure, we consider the T also to be a T0. That is the initial pressure and initial temperature, respectively. Heat is applied. Temperature is changing. Of course, the pressure within the gas will be changing because the volume is not changing. The molecules are moving randomly, bombarding the walls of the container, colliding with one another, giving rise to increase in what? In temperature, in pressure. So as the temperature rises, the pressure also rises. So we can say that the pressure varies directly as the temperature. The pressure varies directly as the temperature. And this is known as the pressure law, when volume is constant. This is known as the pressure law. This is known as the pressure law. It states simply that the pressure of a gas, the pressure of a fixed mass of a gas varies directly as the temperature provided the volume is constant. Right. So over here, what can we do? This implies that P equals KT. And which implies that P over T is equal to K. Hence, we can see that P1 over T1, P1 over T1 will be equal to P2 over T2. We can apply these to any situation under this condition. This at times is referred to as the Boyles Law, but it is generally known as the Plunger Law. All right. Now, these are the three gas laws: the Charles Law, the Plunger Law, and the Boyles Law. I hope this is understood, and I believe we still can make good use of them, applying them to situations in gas problem without any hitch.